Welcome back, physicists. Today it is April 10, 2025, if you're watching this video live, or today, whatever, I don't know. Coming in today, it looks like people might have struggled with a little bit with the homework. So we're going to get some stuff up on the board just to make sure that we have it. So couple things, because we're just going to hit these like really specifically. What is this indicative of? When I write F delta T, almost. I mean, you can think of it kind of with momentum. There's a few ways. First of all, this is the impulse, but it is certainly related to momentum. Specifically, F delta T is a change in your momentum. So how hard is it to change your momentum is known as the impulse. Okay, furthermore, I'll just say rho, this letter, and that's an ugly one, but here it is. Rho is equal to what? This is momentum. And how do you find it? Mass times velocity. Okay, this is momentum. Awesome, we have it. Momentum. Okay, now the impulse momentum theorem gave us the following. F delta T is apparently equal to M delta V. Cool? Or M VF minus VI. Okay, this is everything that we saw yesterday. It is. Force times time gives you impulse because you have to apply a force over some time to change your momentum. Like, that's the only way that we can make it happen. Okay, assuming I don't have any typos, which I'm pretty sure that I don't. Nope, I'm good with this. Let's roll with it. On number 2, they say, hey, use the car that you did a second ago. We had a 725 kilogram car and we had a 2,000 kilogram car. Which one's a compact? 725. So I don't have number 1 in front of me, so I'm going to put this here. M, our mass, is 725 kilograms. Okay, what else do we know? We know the velocity, I think. Okay, so it's 115 kilometers per hour. I'm going to trust your number because I helped several people do this yesterday. What did that come out to in meters per second? Shout it out. We'll see if we get more than one of the same. Be loud, be proud, you're okay. 31.94, 32 meters per second. Okay, so I'm going to call it that 31.94 meters per second. Okay, I'm good with this. Anything else we need? Let's see if I know anything else. Okay, nope, we're good. Okay, on number 2 then, we're going to slam on the brakes hard for 2 seconds. So how should I write that down? You will not be wrong if you tell me how to write something is equal to 2 seconds. Good, delta T. Now, for this, we have to be really careful. Did I tell you or were you told that the car came to a stop? Never mentioned. Okay, there's one more little piece. Over this 2 seconds, we apply a force opposite the direction of the momentum or the vehicle traveling, which is negative 5.0 times 10 to the 4 newtons. Okay, this is 5,000 newtons, right? Is that right? 50,000 newtons. That's a lot of newtons. Okay, this is everything that we have. On A, what does it ask us to find? Is it 10 to the 3? Okay, that's a lot less newtons, but it's still a lot. Thank you for that, Delilah. That would have changed, yeah, that would have killed us. Okay, on A, what do we ask to find? Find impulse and direction. So I'm going to say, if I just say find impulse, and this is me writing it down lazily, right? This is the magnitude and the direction. There will be a sign on it. Okay, so let's check it. Impulse is defined as F delta T. And let's check. What's that force we're using? Negative 5,000 is what I'm going to write here. And how much time did it take? So here's newtons. Here's 2.0, and that's seconds. What's the impulse? Negative 10,000 newton seconds. Okay, baller. Piece of cake. I hope. Nothing crazy there. All right, B's a little bit harder. It said, hey, complete a before and after sketch and determine the momentum plus or and also the velocity. So my sketch, I am a fantastic car driver or drawer. Weird. Both, I suppose. Look at my car. Here it is. Beautiful. Okay, underneath this, I'm going to draw this vector, which could represent a bunch of different things. Could this be the velocity? Does velocity have a direction and a size? Definitely. Does my car have mass? So this could also be mass times velocity or momentum. I'm going to call this momentum specifically. We could call it velocity because we're going to see a similar thing. So if this is my initial momentum, I then slam on the brake, and I don't know how to Machine Gun Kelly this. Here's my new car. Is that right? Is that what skirt means? Is that the noise of a car? I don't know. Cool. All right. What happens to momentum after you slam on the brakes? Does it go up or down? So what should happen with this vector? Boom. Easy. Here's my fantastic hardcore sketch of my car slamming on the brakes and momentum changing. Now, that part is just nice to make sense of it. We actually do the math now. So here we go. My initial momentum. We are going to rely on the work that you've done on part A, or number 1A rather, or we can just calculate out the new momentum. Do we know what the initial momentum was based on your work on number 1 of the compact car? You do. This is 1A. What did you guys get? Or let's just do it. What's the mass of this car? 725. That's my mass. What's the initial velocity? 31.94. And you should have the same value here in just a second. What is this number? Nope. 2. So 2.23 is what I'm going to call that. And there must be an E times 10 to the something. Is it 10 to the 4? Don't trust me, trust your calculators, or both of us. Okay, and this is kilograms for my mass times meters per second for velocity. Cool. There's my initial momentum. Now, for this problem, we are asked to find on B what? We've drawn the picture, all done. Momentum, cool. So I'm going to call that rho final and velocity final. These are what I'm after. Okay, now we need a way to relate these things together, and we're going to use part A in this. If I want to find final velocity or final momentum, is it stuck somewhere related to impulse? I think so, because I just hid this formula. But if I said, hey, what is the formula for impulse? F delta t is how we write impulse. What's it equal to? There's a few ways we can write this. It could be m delta v, or it could be mvf minus mvi, or if I wanted to, could I do it like this? Final, like this is delta p. This is my change in momentum that we see. I think I know a few of those things. Do we know this number? We do. It's negative 10,000. Do we know this number? We do. I have it. Can we just solve this then? Let's do it. Now my final momentum, rho f, is equal to, I'm going to say it's my impulse, F delta t. And how do I get from this line to solve it for rho f? I'm good with that. Let's just add my initial momentum. I want you guys to finish this problem if you haven't yet. Delilah, did you finish this problem? Okay. That's fair. Very different energy in here. Just as lively. Ball. So it feels silly because I'm struggling to do this at 12.3, 12,300. Okay. And if I'm thinking momentum is mass m kilograms times velocity. There we go. Okay. Now, with this, did we come to a complete stop? I don't think so. My momentum on part A was positive. My momentum here is still positive. It's gone down, which means I better slow down a bit, but I haven't come to a stop. Okay. If I had come to a stop, what would my final momentum have been? 0. That would tell me that we're stopped. Okay. We're not. Here's the momentum. Awesome. We have it. What else was I asked to find? The velocity. So I'm going to go one step further, expand out. Just if I wanted to find momentum, rho, it's mass times what? Indeed. Okay, here it is. I'm pretty sure you said mass and velocity. If I know, do I know rho f, my final momentum? Do I know my mass? Can I just divide both sides by m? Yeah, let's do that. My final velocity is apparently just my final momentum divided by my mass. And when we plug that in, it looks like it's 12,300. And I'm going to do a little double check in here. That's kilogram meters per second. And that's going to divide by, what was my mass? $725. And that's in kilograms. So if I'm dividing by kilograms, I'll just do this. 1 over kilogram. Do I wind up with what should be velocity? Meters per second. Hey, that's a good sign. Unfortunately, I have no idea what 12,300 divided by 725 is. 16?
16.96, yeah.
Meters per second. Awesome. We have roughly halved our speed. Now, if you're to check online, they use bigger rounding because they're paying attention to the significant figures, something that I don't stress very hard. I'm good with this. This is a better answer than the book gives, but we're being fast and loose with those decimal points. Cool. This is pretty close to like 63 kilometers per hour. So we went from 115 to 63, about half. Cool. We done. The car's final momentum is 12,300 kilogram meters per second, and it travels at 17 meters per second. Done so. Okay. We looked at number 2 just now. You guys had 5 problems, right? Okay. I want to give you guys a chance, but I need your input. Do you want to do one more? Do you want to do 3 together, and then I'll have you guys do 4 and 5, or do you want a few minutes to do 3, 4, and 5? Read 3 before you commit to a decision. Okay, so looking at that problem together, I was going to draw a picture, but I don't really need to draw a picture. You guys want to try it together? Do you want to talk about it first? Try it? Cool. The figure that they're referring to, remember, we looked at how to calculate momentum, or impulse rather, from a graph, right? It was simply, if they give you a force and time graph, how do you find the momentum or the impulse? It's the area. You are given two different figures in your book, right? Can you tell me the impulse on the top figure? 5? Okay, trick question, sort of. Totally, this is going to apply to you too, but I'm going to ask you to hold off a second. How about the second one, the bottom one? What's the impulse there? -5. Why negative? I agree with you. What? Because it's underneath. It's negative. Cool. I'm good with that. Okay, so we have +5 and -5 impulse. I will give you guys a second. We were looking for the speed and direction after each impulse. So I will start setting this up. I'm going to pause it. I want you guys to play around with it, though. I don't get it. All right, check it out. Impulse momentum tells us the following. The impulse, F delta t, is equal to what? I like the second you added that second word is what I liked. Are you okay if I write it like this first? Okay, so I know that's true. This is the what? What's the name of this equation? The impulse momentum. Okay, so check it out. There is a change in momentum that's going to happen, and I know it's this big. So if we plug and chug in through here, let's just kind of see what shakes out of it. We are trying to find what in the end? Velocity. Okay, we're looking for the final velocity after our first impulse. Okay, so let's do that. I need help rearranging it though, or even adding more to it. We get F delta t. I don't know why that came out as a subscript. Let's just replace, just because I'm looking for velocity, let's make sure velocity is written here. It's m vf, right, minus m vi. In this, what are we actually trying to find? We are looking for vf. Okay, find vf. Lovely. Do you know, and I'm going to call this final impulse if we want to. This is a situation I'm thinking about. Do you know any of these numbers? Or can we solve for vf right now? We can't? Let me rephrase that. Without plugging in stuff, help me rearrange this equation, and I want only this on one side. Because that's what we're after, right? I'm going to do two things in one step. What's the first thing you guys would do to solve for VF? You would subtract it? Are you sure you would subtract it? How do you subtract it? So I'm going to add it with the mass, right? Because I can't just subtract the other one. Then what? Divide by mass. Okay? And then that would leave me with just VF, right? So let's just check. Do we know in this first impulse the value of it, like how big it was? What was the first impulse that we felt? Here's 5. Plus, now I don't have it written down, but I think that we can probably reason it out. What's the mass? 7. And what's the velocity? Anybody opposed to me just writing 14? Because 2 times 7. Okay, over, what was the mass again? 7. I think I can do this. Let's see, 5 plus 14 is 19, divided by 7, gross, 2 point something. 2.7, I'm just going to call it 2.7 meters per second. Now, it was a positive impulse on a positive direction. This thing sped up or slowed down? Obviously, we can see it here, I guess. It sped up. Okay, now this is where this problem gets weird, because this is after the first impulse. The second impulse is going to speed it up or slow it down? Slow it down. Now, your gut is probably going to tell you, and I guess I don't know what your gut's going to tell you. I want you guys use this rather, as your initial velocity for the second impulse. because this is the new speed that we're at, right? So I've gone, something happened, it sped up. Now this is our new initial velocity currently, and we're going to add another impulse. I want you guys to do the same, where we're going to let this be VI of second part. Cool. I want you guys using this as our new initial velocity for the next impulse that's going to happen to run with it. And I'm trying to decide if I'm misinterpreting.
It's confusing, right, Ollie?
Nope.
Oh.
I mean, I'm just rereading it to make sure, because it says that they both happen one after another, right? Yep, so now we just got to deal with this. Are we going to be able to use impulse momentum again? Probably. I'm just going to switch colors because it's a different one. The problem doesn't really look much different, I don't think. So there's a couple little things that need to change. I just jumped to here, just so you know, I didn't want to redo all the algebra. So this step, I knew it was going to come out to be the same equation. And let's just, once we're here, I agree that -5 changes, but something else changes. So this is what you suggested, right, Nick? Okay, I like it. What's the mass of the object still? But assuming that these impulses happen in the order that we, determined, what was the initial velocity of it before it got struck the second time? Like, check it out. Here I am. I'm going constant, and then impulse happens, and I speed up, and now I was going how fast according to the first work we did. Like, there's no thought. We just have to find how fast do we wind up after the first impulse. Good. So an impulse of 5 sped us up to 2.7. An impulse of -5 now. Is it going to slow us back down to exactly 2? I don't. I would call it 1.99. This is what I come up with. 1.99. About the same. So if we think about it, I think it makes sense. If I add momentum this direction and then I undo that by doing the exact opposite, it should slow it down to about the same, right? Why didn't we get exactly 2? Like, we didn't do anything wrong, but any thoughts on what we might have done incorrectly? Not keeping the entire decimal. This is a little tiny rounding difference is all that we're seeing here. Cool. All right. You guys have 10 minutes. I would suggest impulse momentum. Use impulse momentum theorem. I want you guys to knock out 4 and 5. Cool.